So really thrilling to have you with me, Linfa. We talk relatively regularly, which I feel very privileged to have that access to you. For those people who don't know who Linfa Wang is, Professor Linfa Wang, Linfa for me is a scientific mentor. I'm 44 years of age now, Linfa. You trained me in my honors degree when I was 21.
Yeah, that's right. So more
it's
than
a real,
20 years of,
Totally. It's like the same amount of time that age I was then has passed since now. And it feels like a coming home, like a full circle.
Yeah.
I get to come back and chat with you. And I can tell you, my mum, she adored you. She thought you were wonderful. And
thank you.
You're one of the, I've lost now, gosh, in the time that's passed, I've lost my dad, I've lost my brother, I've lost my mum. And each of those three funerals, I can't recall anyone else from my sort of career or professional life attending the funerals, but you came to my dad. So you've always held a special part in my heart. Let me introduce you. You're the Professor and Director of Emerging Infectious Diseases at Duke National University of Singapore. You were my supervisor at the CSIRO Australian Animal Health Laboratories, which has now changed its name. What's it called now?
Yeah, Australian Centre for Disease Preparedness, ACDP. Yeah.
Okay, so that's a telling of the times, right? So,
yeah, that's right.
And you moved from Australia to Singapore. And my kids would be really thrilled to know that I'm speaking to the Batman.
Thank you.
Which is what you're affectionately known as in the scientific virology world. So why don't you say a little bit about what keeps you busy now? Because I mean, as far as I can tell, you're one of the most important scientists on the planet right now.
I would not put that far, but certainly, I would be in the maybe top 10 in terms of emerging infectious disease, and certainly, like when we were birthed in CSIRO that 23, 24 years ago, actually I started then, and not too long after I started, you came. So I guess one's life is always a combination of your effort and the luck and and your training. Like I was lucky I have Brian Eaton as a mentor of virology. Although I have no formal training in infectious disease and virology, but as soon as I arrived in CSIRO lab in Geelong, then I got really good training. And fast forward 25, 30 years later, now, obviously I experienced from the Hendra Virus in Australia, Nipah virus in Malaysia, Singapore, and then SARS in China, 2003, and then MERS in, from Middle East to the world. Ebola, I was associated to some degree, and now I'm really into this COVID-19. I sit on multiple committees for WHO and other international organizations. So for somebody who did not have an infectious disease virology training, I felt really fortunate. My life is kind of all covered in that whole spectrum,
Yeah. When it comes to emerging infectious diseases, you're like a grandfather in the field now. I mean, you're newly a grandfather in reality, but
that's right. Now I was lucky. I said, I was old enough to play an important role, with Hendra, and I'm young enough to stay active in COVID-19. So in this generation of scientists, most of them who played a role in Hendra and Nipah already retired. So I'm still active. So in that regard, I was lucky, right time, right place as well. Yeah.
I'm at that age now, Linfa, where I'm kind of reflecting back on just like some of the people that were key influences to me in my younger adult years, and just looking back, considering you were only you were 38 or something when you were mentoring me, and I just think, oh my gosh, you just occurred. You've always occurred as like this wise sage. I always hung off every word that you ever shared with me. So it's just thrilling to kind of full circle, like I said, come back into your life and seeing how I might be able to contribute and maybe participate somewhat in helping to end this pandemic. But let's go back to, I want to ask you a couple of questions about Hendra virus, because it seems like in the world of emerging infectious diseases, that's where it kind of started. And this zoonotic agents, can you explain what that is, what that means?
Yeah, so I mean, zoonotic zoonosis means that it's a pathogen jump species. Usually we refer this animal to human jump, but now for COVID-19, we know that it can jump backwards from human to animal as well. So,
and that's scary,
so
right?
Yeah, that's right. We have a more specialized terminology. One is we call the spillover. So spillover is animal to human, and then spill back is human to animal. Yeah. So Hendra definitely, I think, marked the first lethal virus. We're talking about, virus comes and go, right? But then you have certain viruses that it's much more lethal, and Hendra is the first one that has a fatality. So if people get infected, more than half of them will die, so that's very scary. And also, Hendra is the first really highly lethal virus identified as a zoonotic agent that jumped out of bats, so that's in 1994, 25, 26 years later, now everybody take bat seriously, but in those days, we did not know that bat harbors so many dangerous viruses. Yeah, so that's certainly it's a milestone. And then personally, I have the sort of privilege to eventually name the virus, because initially it was called the equine mobility virus. And then we thought, it's not a host virus and it's not a mobility virus, so we rename it as Hendra. And unfortunately, scientists have to have a name, so for people living in Hendra outside of Brisbane, they were not very impressed.
But you also worked with a pharmaceutical company to develop a vaccine against Hendra. I mean, that is just an extraordinary accomplishment.
Yeah, so that remains to be the only vaccine against what we call a biosafety level 4. So when we talk about virus lethality, fatality, there's actually a formal classification, depends on how lethal they are and whether we have vaccine or drugs. So it's a combination of different criteria, and then we classify this as a biosafety level 1, 2, 3, and 4. So HIV is 3, COVID-19 is 3, but Hendra is level 4. So far, nobody have developed a vaccine which is actually licensed and commercially available. So we were the first. So that was another, personal, I think, a highlight, because as a scientist, I'm not very good in commercialization, but I had the opportunity to talk to Pfizer Animal Health in those days. They're headquartered in Melbourne. So I went there to say, for a company like Pfizer, of course, they go for P for profit. But I said, I'm a scientist. I want to work with you. If you're interested, let's do a P for profile, right? I say, would you like to work with us to, manufacture and commercialize the first ever vaccine for a BSF4 agent? And they came on board. And a few years later, we had this Hendra vaccine, license for using horses. And it remains the only licensed vaccine, whether for human or, animals, for BSF4 agent, so that's kind of quite impressive.
What about for lower classified agents? Has that kind of vaccination strategy been employed elsewhere in terms of vaccinating animals with the intention to protect humans?
Not really. So this is what we call one health now, so one world, one health. So traditionally, people working with animal virus and human virus don't work together. And so I was the go-between. I worked in the Australian Animal Health Laboratory, but the virus, mainly impacts human, right? So that's why we came up with this concept of one health vaccine. You vaccinated animals to prevent transmission to humans. So this is the first time this concept ever used and remained only licensed one health vaccine. Of course, right now people start to, copy that concept. So they are talking about to make a MERS vaccine for camels, and then a COVID-19 vaccine for minks. For example, mink farm, has had a very, very tragic, outcome. Like in the whole Netherlands, mink farm is basically gone. They cull all the minks to prevent transmission.
Yeah. Wow. So then from Hendra virus to Nipah virus in Malaysia.
Yeah.
And I remember that was at the tail end of my time at CSIRO with you. I finished my honors degree, and then I stayed on. You helped me get like a sort of vacation scholarship to continue some work. And it was kind of like exciting times when this outbreak was happening in Malaysia and scientists were coming in from the CDC in the US and then to Malaysia and so forth. And so you were involved in that as well. Did you name Nipah virus?
No. Nipah was named by my close friends, Dr. Galbin Charles from Malaysia. So he basically followed our kind of a tradition of naming the virus using a suburb or a village and of the index case. So Nipah is a village outside Ipoh in Malaysia, and that's where the index case of Nipah outbreak happened in a pig farm. Yeah.
And then SARS. So
yeah, SARS, I think, I mean, Hendra and Nipah are big in terms of their fatality and in terms of my career, and also in terms of we put bats on the map to say they could be important sources of emerging killer viruses, right? But the real international stage, in terms of general public, of course, it's SARS, because SARS not only highly transmissible, but has a fatality of 10%. And it rapidly, really, the virus, went to more than, 20 countries and touched all the continents. So not like Hendra is mainly Australia, Nipah is mainly Malaysia, and across border to Singapore, where the SARS is a truly international. And in today's term, it would be called a pandemic. Those days we just call a outbreak, right? And Australia was lucky as an island country. We did not get a single human case. So most people thinking that if you have no cases in your country, scientists could not really contribute to the international effort. But at that time, I think our director, Martin Jago, he came from animal health kind of a background, but has a very strong interest in One Health and emerging zoonosis. And basically he says, Linfa, we need to be in that game, so you speak Chinese, and let's get some Chinese collaboration going. But on personal level, you can have collaboration, but the impact will not be the same. And then the right time, right place, because our Australian virologist, Professor John Mackenzie, who is very internationally known and was seconded to WHO to lead the scientific advisor board for SARS, basically, in 2003. And so John first invited me onto that scientific advisor board for WHO. And then in July, August, the pandemic was already, under control, not like COVID-19 going on and on, SARS was really explosive, but through just quarantine and the social distancing and the banning travel, the international community with the leadership of WHO was able to contain that pandemic by July. So it's basically a half year, pandemic. But at that time, human infection has been stopped, but we still did not know how the virus, transmit. I mean, we have a very clear idea it's from animals. So that's why WHO assembled a mission to investigate the origin and early transmission event. Just like the mission, just complete in Wuhan for COVID-19. The difference is that mission is more about science rather than politics. And the last mission, or this current mission, is just too political. But anyway, I was fortunate enough to be selected as one of the 8 international experts on the mission. And I was the only one basically lab-based. All the other 7 are more epidemiology, zoology, So, and then through that mission, I established a collaboration with Chinese, US, Australian scientists. And 2 years later, we identified bats as the natural host. So that's certainly is on a different scale, The work with Hendra and Nipah laid the foundation. But in terms of international impact, I think the SARS was the one really pushed us to the world stage,
Now you had the history though of working with Hendra virus and Nipah virus. Both were established to have come from bats. What was the kind of general view when you were there, part of the team investigating SARS and its origins? I mean, you would have occurred to you as pretty obvious, like let's look out for the bats. what was everybody else saying?
Not really. This is 2003. Even for myself, I started the Hendra work in 95, so, this is 7, 8 years later. And the research into bats and the viruses was at its infancy, right? So even for myself, I mean, as a scientist, you don't propose something until you feel confident, there's a, scientific justification. So during the WHO mission, we went to Beijing, Guangzhou, and Shenzhen. So only after the visit in Guangzhou, because that scientist in China says they sampled lots of different wildlife animals. Some are truly wildlife, some are already farmed, and others are smuggled in legally or illegally, to Guangzhou. And then, we were able to go through the raw data, and I found a few bat samples were PCR positive. But these are on the borderline positivity, and they could not repeat. And then, other members of the team basically says it could be contamination. So, that's the only line of scientific evidence we have said bats can be potentially be the source. And so I thought about it, and then also I thought about, even for Hendra Nipper, it took us really hard work to nail down that origin hypothesis. And then, it's not going to be easily accepted because bats are very difficult to research, and plus not too many examples of bats as an important reservoir. That was like 17 years ago, right? So during the last week of the mission, I started really pondering that myself. And then after some kind of, strategic brainstorming with my team leaders, I said, research funding is very limited. If I can only bet on one species, I'm going to bet on bats, So even for the WHO team at that time said, good on you, basically says, I would not be doing that. It's too difficult. And then I talked to the Chinese scientists in Beijing and Guangzhou, most people say, okay, Linfa, I know you love to work on bats, but it's too hard. And also the chance of success is so low. So, thanks, but no thanks, So, and then until I, through an indirect sort of introduction, was introduced to Dr. Shi Zhengli, in Wuhan Institute of Virology. And now she is the very famous bat woman, but in those days, she was working on fish and shrimp viruses,
Right,
So, but
wow.
she loves field work. And so as soon as I approached her, say, are you interested to collaborate to sample bats and really looking for the possibility of bats also as the source of SARS virus. And she got very excited. Then the rest is history, right? We have been collaborating for 17 years, and we co-published more than 40 papers, and many of them are in top journals, Science, Nature, PNAS, and things like that. So it's just been an incredible, journey. Yeah.
Yeah. Wow. And it's kind of funny for me because you don't have pets, right?
Yeah. I mean, I don't have pets when you were in Geelong, and then later my kids insisted, so when they went to high school, we allowed pets, but I still don't, because I grew up in Shanghai without pets, without any animals, Yeah.
And now you're so intimately related with bats of all the animals.
Yeah. My whole career, journey is almost a science fiction, because I never had the interaction with animals when I grew up, and I never liked it. And then, after the Cultural Revolution in China, they started university. So I did not put any preference even close to biological science. I wanted to be engineer, And then through another accident, because I performed above the university I selected for, and then they put me in a high tier of university, but because my math was not good, and said, you're only good enough for biology. So that's how I started all my biological career, So even studying biology was not my intention, and doing bat research certainly was not in my even the wildest dream, Yeah.
Gosh, who would have known? Who knows what would have happened had you've gone down the route of mechatronics, which was your dream, right, as a kid?
Yeah, that's right. Yeah, yeah, we don't know.
Oh, wow. Well, fast forward to now, like 17 years post SARS, then there's another outbreak. SARS-CoV-2. So you were in Wuhan in January of last year. What were you doing in Wuhan? Just, I assume you weren't holidaying.
No, so because my close collaboration with the Wuhan Institute of Virology, I go there now, after I moved to Singapore, because it's a 5-hour direct flight. So I go there 3 to 4 times a year. And when they have an annual retreat, scientific retreat, when their students present and things like that, they always invite me there to give them advice and also formulate, paper ideas and things like that. So that was supposed to be in December 2019. So, and then the CEPI, so this is the International Coalition for Epidemic Preparedness Innovation. So CEPI is big as well because they are a non-profit organization established to really rapid development of vaccines, for exactly things like Nipah virus, Hendra virus, and the COVID-19.
Because just to explain that, and that's because big companies may not want to invest in the development of these vaccines because they may be short-lived and there won't be a profit opportunity for them. So we need a pool of funds available for the rapid development.
Yeah, exactly, because emerging viral diseases are very different chronic diseases. If you invented a vaccine for HIV or hepatitis C, any big company will jump onto it and invest like crazy, right? Because they know there is a market. For emerging infectious disease like Hendra, Nipah, SARS, even MERS and Ebola, right? Even if you have a vaccine, by the time you have a vaccine and finish the clinical trial, most likely the pandemic will be over. So COVID-19 is the first time in mankind's history that we actually have a vaccine development license when the outbreak is still ongoing. Okay, and so CEPI came in after the really Ebola and the MERS outbreak and the SARS outbreak to say we need a consortium, basically, almost like a public good type of effort, but you still need the scientists, you need a private industry, and you need the philanthropic and the government funding body. So that's what CEPI is. So 2019 marks the 20th anniversary of the Nipah virus first discovery in Malaysia. So CEPI want to sponsor a conference called the Nipah at 20, all right? And I had the privilege to discuss that concept with the CEO, and Richard was very keen to say, if you can do that in Singapore before the end of 2019, then you have the, a sponsorship. So that's what I worked from March to December very hard. And we had this fantastic scientific conference in Singapore called the Nipah at 20. And I invited the key scientists from Wuhan Institute of Virology and the China CDC. So when the SARS-CoV-2 was incubating in Wuhan, we did not realize, because this is December 9th to 11th, in 2019, all the world leading scientists, Peter Daszak, all the big guys were in that week was in Singapore, because we were here to really get to the bottom of this Nipah 20th anniversary. And so for that reason, I delayed my trip to Wuhan. So I could be in Wuhan in December if without this Nipah F20, so I don't know which one is a better month, but anyway, I went there and we delayed that by a month. And then the annual scientific retreat was on January 15th of 2020. So I arrived in Wuhan from Shanghai on January 14th, and then by a high-speed train. And then I left in the early morning of January 18th by direct flight from Singapore from Wuhan to Singapore. Yeah. So I was there for scientific reason, but I did not go there to investigate the COVID-19 because at that time, COVID-19's name was not established. And plus at that time, I just knew there was a novel coronavirus called pneumonia, but we never predicted it would be that big.
And when you were there, I mean, what was it? At what point was it? Did you decide for yourself that I've got to get out of here, or were you told to leave, or how?
No, nothing like that. Nothing like that. Life is as normal as it can be, So this is the thing I said, I mean, in the media, there's talking about cover up and things like that. I mean, I don't want to go there, but I think in terms of the general public and the scientific community, you know, it's not panic. It's just kind of anxious, all right? People want to know what's that novel coronavirus, you know. By then I arrived, we already know there's novel coronavirus and the sequence already published, you know, 80-something% identical to SARS-CoV-1, you know. For general public, they don't know what that means, right? So the key thing I think, you know, is the Chinese authority keep saying that, you know, the main cluster is associated with the Huanan seafood market, you know, so it's animals were traded in the market, and there was no strong evidence of significant human-to-human transmission. So this, you know, in retrospective, this is a diplomatic language. Basically says, you know, it could be human-to-human transmission, but we don't know, basically.
Yeah.
For that reason, you know, I, as you know, a scientist working in the field for so long, and also the scientists on the ground in Wuhan, the doctors on the ground, and you know, you go to the hotels, you go to the MRT, bus, railway stations, people don't wear masks. You know, for Asians, whether it's in Wuhan, Hong Kong, Shanghai, you know, if people worry, the first thing people do is wear masks, right? So when I was there for that 4 days, I did a little bit of a survey myself. I just look at the MRT station, counted to say how many people wearing masks. It's around 1 to 3%. That's very normal during winter of any city, right? So people are wearing masks not because they're scared of this novel coronavirus. They're wearing masks just because there's a common practice. In winter, they like to wear masks, you know. So, yeah. So for that reason, nobody was panicked, and I was not panicking. So I did not leave the city because of worried about the infection. I left because everything, you know, 4 days is the maximum I can spend, right? But at the airport, the Wuhan airport, you know, the international airport, and then you realize normally when you arrive at the airport, after you check in the luggage, you just go all the way to a passport, you know, checking and the security. This time there was an extra layer. You are not allowed to go to the hall. You have a long queue there. I say, what's going on? Or they say, you know, there's a temperature check. I mean, you have gone through the passport, the airport with temperature check. Usually there's one sort of a video there, and then the infrared will measure your temperature, you know, that's it. But this time in Wuhan, no, 3 different, you know, videos point at you, and you have to walk slowly in a group of 4. Wow. If any of them shows anything unusual, you come back and walk through again. So that's why it delayed. The queue was very long. And then you have people, all these medical staff members dressed in PPE with masks. And then you have a small room there, basically they're ready to give you diagnosis and check up, you know. So that is like a war zone. And then that immediately let you feel to say, oh my God, it's pretty serious. But in the society, you don't see it. At the airport, you definitely see it. So I think what the government was trying to do is to prevent anybody has the remote chance of being infected to get out of Wuhan, basically, yeah. So that's, you know, in the morning of the 18th. And then by the 20th of January, the authorities had a press conference, and the famous Professor Zhong Nansen basically says, we have clear, solid evidence now this virus is capable of human-to-human transmission. You know, so as somebody who has worked in emerging infectious disease for the last, 2 to 3 decades, to me, that's the dividing line. Before January 20th, you have an excuse not taken seriously. After January 20th, whether you're Chinese or foreign nationalities, if you don't take seriously, then you cannot have any excuse that you have not been warned, right? You know, a totally new virus is a cousin of SARS and is capable of human-to-human transmission. And then 3 days, that's January 20th, right? 3 days later, January 23rd, the government shut down a city of 11 million, you know, so that's, in mankind's history, that has never happened. So again, you know, so for anybody to say we will not warn, you know, we will not warn how serious that thing is.
Well, do you think the success of containing SARS is that it didn't go beyond countries that in fact do take it seriously? Do you think the breakdown with this outbreak to pandemic has been post January 20, it just wasn't taken seriously by many countries? Do you think that's the defining thing?
Oh, as I said, before January 20th, Chinese can do better. If they announce human-to-human transmission 1 week earlier, right? And then after January 20th, then agree with you. The other nations have not done their job because, you know, the SARS already says that for something like that, you don't have treatment, you don't have vaccine, you know, quarantine and containment really is the most effective way of doing it, but you have to do it early.
Yeah.
Right. And, you know, most of the countries are not taking that seriously. And then you can see the nations affected by SARS, you know, nations, all regions affected by SARS, you know, Singapore, Vietnam, Hong Kong, you know, Taiwan, all did well because they suffered the most during SARS, you know. So
yeah,
it's sad because you know, the lessons only learned through loss of life, basically, you know. So
yeah, wow. Well, I mean, there's lots that we could talk about with regards to COVID-19, but let me ask you, what are the myths? What do you hear? What are the biggest myths that kind of have infiltrated the public, that's confused the environment? If you could make something clear or one or two things really clear for people, what would that be?
I think, you know, depends where you are, right? You know, like in Singapore, we don't have myths. The government is very good in educating and very science-based, right? You know, so to me, I think, you know, I always say, like my research right now focuses on two questions. How did the virus get into human population? Basically, how did COVID-19 start?
Yeah.
And then how can we get out of this pandemic?
Yes.
All right.
Yes.
So, and then the myth surrounding these two fundamental questions is really making the scientific progress and the international collaboration slower. So myth number one is how did it start, right? You know, so you go from it's a bat to animal to human transmission to it's a man-made virus, intention released to kill people,
yes.
Right? You know, so these two extreme kind of scenarios, you know, the measures and the international collaboration will be totally different, right? So that's the number one myth. I think is unfortunate. You know, I mean, every time you have outbreak, like even the Hendra outbreak, you know, people thinking that was a man-made, and the SARS certainly is true, but never had the oxygen of this COVID-19, right? Because, you know, we have powerful world leaders who are promoting this kind of conspiracy. So that's number one. Then number two now is how can we get out of this? You know, I mean, this is already going more than a year and the people are going crazy, right? People say, you know, we may have, you know, more people die or go crazy than the infection, you know, because the mental health, the economics, you know, the society fabric of the stability of the society. So it's a tough question. How can we get out of this pandemic? You know, so the scientific advance is incredible, right? You know, we have a vaccine basically from concept to license in 8 to 10 months, you know. I mean, this is just the unprecedented, and also mRNA vaccine has never been used in human bodies, and now this is the front runner. You know, I just had the 2 injections already myself, you know, right?
Well, talk me through that process, given it's so new and the safety profile is maybe a bit uncertain. I mean, what did you have to deal with yourself to make the decision to get that vaccine?
Because I think, you know, we're living in a real world here, right? You know, risk assessment and risk management is the only way out. Because risk avoidance will never work for COVID-19 because it's such a widespread disease already, and we only are learning the very, very sort of little aspects of this you know, virus and in terms of long-term impact, okay? And so on the other hand, the vaccine is totally new. mRNA has never been used as a vaccine for human beings, right? And so basically you have the risk of not taking a vaccine, because I view, you know, as a scientist and as a global citizen, you take a vaccine for 2 purposes. One is hopefully, you know, that will prevent you get an infection, or even if you get infected, you will not develop severe disease or die. But to me, I think, you know, more important, because I think I have a lifestyle and self-discipline, I can, you know, minimize my own infection chance. But then as a society, half the reason is for the society, because that only when the majority of population is vaccinated, impact the vaccine can play a role. If you know, most people thinking that I'm young or I just, you know, do social distance for the next 3 years, I don't want to have a vaccine, then if the herd immunity is not reached, then even if somebody is vaccinated, as a society or the global village as a whole, we are still at risk. So with these two, you know, driving forces, and for people like myself, and you know, I think it's an easy decision, right, to take the vaccine. You know, I also have a selfish reason because I want to do research on myself. You know, so after vaccination, I'm going to monitor my immune response and things like that. You know, so
well let's talk about that, because you've developed the world's only, I call it, the test that can measure functional immunity. Is that a term? Did I just make that up? Functional immunity. I like using that term. It kind of makes sense to me.
Oh, definitely. You know, functional immunity, you know, means that when you get an infection, your immune response comes in all sorts of shapes and forms. So the two big arms, one is what we call cell-mediated immunity or T-cell immunity. The other we call humoral immune response, or mainly is the antibodies, you know, your B cell produce and it circulate in your blood system, right? So then no matter what infection you get, whether it's virus, bacteria, or parasite, you get hundreds and thousands of different antibodies, which will all bind to the pathogen. So we call them binding antibodies, okay? And, you know, I don't want to say they're not functional antibodies because I think that they function in a different way, but the main really important functional immunity, I'm talking about the arm of the humoral immune response, is carried out by a very small subset. We believe that for most of the infection, it's only 1 or 3% of the total antibody direct to the most important part of the virus and carry out that function called the neutralization. So basically, these are the functional antibodies. Once they bind the virus, they can prevent the virus to infect new cells, and hence it's neutralized. The virus sort of activity is neutralized, and these are defined as neutralizing antibodies, okay? So neutralizing antibodies are, I think that's no debate. Neutralizing antibodies are the most important functional antibodies. The debate is about neutralizing antibodies versus T-cell immunity, which is more important. And then I think scientifically, both are important, depends on the individual, different pathogens. But the general consensus is that antibodies circulating in your blood system, so it's the first line defense. For example, after vaccination, you know, you have the antibody and the T-cell immunity, but the antibody is circulating. So if you want to prevent infection, means that if the virus is in the air, you breathe in, and that if you have high neutralizing antibodies, it will reduce the chance for the virus even to start to replicate and infect your body. T-cell will not do that because T-cell are cell-based. T-cell will only be activated when the virus is already replicated in your body, and then your immune system sends to say, oh, I have enemies just in my neighborhood, and I'm going to go there and kill them. So T-cells are second line of defense. So we always say that, you know, antibodies first line play a role in both prevent infection and reduce your symptom. T-cell is more the second, is to reduce your symptom.
Yeah. So it's really all about the neutralizing antibodies. So you've got variability with regards to the vaccines, and there's different numbers around efficacy. We won't even go there. So you got variability there. The virus is changing. You know, what's the reality around the mutation rate and the different strains that it's kind of creates a bit of panic in the public? What's the reality around all of that?
Well, for scientists like myself, you know, it's totally within our expectation because, first of all, in the world of viruses, we, you know, grossly divided them into two. One is what we call the RNA virus, and one is the DNA virus. You know, for the general public, you don't have to worry, you know, what RNA, DNA. It's just the RNA virus that's have a higher mutation frequency than the DNA virus. So if you encounter the RNA virus, it's natural to mutate, okay? And so this is number one. Number two is among all the RNA virus that we know exist on this planet, coronavirus happen to have the longest string of genetic code on one segment, one basic genome. Influenza virus, for example, we know that it mutates a lot as well, but because RNA is unstable, so virus devise this strategy. If I want to, maintain this stability of the genome, you can segment them. So flu virus have 8 pieces of RNA. So if one piece goes wrong, then you can replace that one piece, the other 7 can still function. Coronavirus is the only one on Earth that has the longest genome. It has more than 30,000 nucleotide genetic codes on one piece, okay? So itself is a research topic. We still don't understand why this can survive, because when you mutate, have a large genome, you have more errors and you can die out the virus. So coronavirus is very, very unique. And so in RNA virus, the WHO, the first mission they sent to Wuhan was in February. And in the report, one of the highlights say is that SARS-CoV-2 is relatively stable as an RNA virus, okay? So, but you still have 30,000 nucleotides. Any one of them can change. And we know now it has passed at least through 100 million different individuals. The real number is high then. Confirmed the case is 100 million, all right? So imagine that the virus in one person's kind of body, it stayed there for days and weeks. And then it replicates many, many times in your body. So to me, the mutation events for this SARS-CoV-2 is totally within expectation. And I think that the variants we're seeing is actually says the virus is relatively stable, okay? And so that's, I think, just a given. I think, of course, we need to be concerned and we need to monitor that, but COVID-19 or SARS-CoV-2 certainly is within the normal RNA virus genetics, and evolution.
Well, what I like about the story around neutralizing antibodies, the receptor binding domain part of the spike protein on the virus, its ability to interact with the protein on our human cells, the ACE2 receptor, then that protein interaction must be so highly conserved that it would very rare that there would be a mutation that would increase or decrease that interaction, right? It just needs it. So if we're developing neutralizing antibodies, that need or the vaccine efficacy in that regard, it won't matter what variant of virus, right?
Yeah, so these the premises for SARS-CoV-2 is because, through SARS-CoV-1, we have done so much studies already. We know exactly which part of the virus, now we call receptor binding domain, RBD, that's the protein with a fixed structure that interacts with the cell surface protein we call ACE2, which is the entry receptor on human cells. So that interaction is well defined, 3D structure is solved, and the virus will change, right? But there is a minimum space, room for them to move, basically, because if they change it too much, means the RBD will no longer bind the ACE2, and then evolutionarily they will be selected out. Okay, so that it's like what we did. I collaborate with Professor Chris Brodo in USA. So we not only developed the Hendra vaccine, but we also developed a therapeutic monoclonal antibody, and that monoclonal antibody, by luck, just mimics the receptor binding. So the receptor for Nipah and Hendra virus is the heparin B2 molecule on our cell surface. So this make a contact with the virus, and Chris was able to, and with Professor, Mitko Dimitrov, and they developed a monoclonal antibody which mimicked the receptor molecule binds to the virus. So yes, the virus can mutate, but the virus will not mutate so much that it will not bind the receptor, because that, it's a suicidal mutation, right?
Yeah.
And so I think we are seeing a little bit of this here with ACE2 and the RBD of SARS-CoV-2. Of course, there will be mutation, but the general neutralization of vaccine should still work. But again, it's all individual immune response. As I said, an individual get infected by SARS-CoV-2 will produce hundreds and thousands of different antibodies. They bind to different parts. So if one individual binds to the parts that now is changed as the majority, and that person will be impacted the most, but not everyone vaccinated, right? The majority of people vaccinated should still have enough neutralizing antibody to deal with what we call this the variants. Yeah.
So then what's the answer? Okay, so you've got the variability with regards to the vaccine efficacy. The virus is changing. You're saying that's not going to be long-term a significant phenomenon, but then there's variability in the immune response. So, I think, so we can measure neutralizing antibodies and really have that be the target. Is that what's going to make for an effective exit strategy?
Oh, so I'm biased. Of course, I'm going to say that is the one, because right now there's two arms of immunity. One is T cell immunity and then one is B cell immunity, which is neutralizing antibody. For an exit sort of a strategy to work, we have to have a tool in our hand, which is powerful enough to measure the functionality of the immunity, whether it's T cell or the B cell immunity, which is cheap enough to implement on large scale, and which is convenient enough, to be deployed. Imagine if we have another neutralizing antibody test, or the T cell test need a -80, cold chain. That's not going to happen. I mean, for vaccine, it's already difficult, and then for a test, So that's why I think, to answer any of these concerns, our only way out is to have a functional way to monitor immunity. Okay. So for example, it's clear after you're vaccinated, there's individual difference, right? And so who can prevent an infection by a known variant or future variant? I think the scientists will all agree if you have a very high level of neutralizing antibody, you have a less chance to be infected by any virus, including variants. Okay. So some even hypothesize that, if you have a lower immunity and then you select for a variant which can escape that immunity, all right? So some people is already hypothesized whether, vaccine trials in certain regions that in the early phase with a not so effective vaccine actually select for variants. Okay. Wow. So this is a very complicated scenario we have right now.
Yeah.
Right. On one hand, we're worried about with the vaccine, current vaccine will protect against the current variants and the future variants. On the other hand, we know that if you don't vaccinate the large population, you give them more chance to develop variants. And now there's a third scenario to say, if you half vaccinate, like one dose, or you vaccinate with a less potent vaccine, you accelerate a generation of variants. I mean, I'm lucky I'm a scientist, if I'm a politician, how do you make a decision out of all this information, right? To me, the only way out right now is to increase production and the mass vaccination as soon as possible. And that has to be done across the globe, because that if it's only done in certain developed nations, and then you force the developing nations to incubate and produce variants, and then they come back to, if these variants are really so different, then, even the vaccinated population, because that, first of all, individual variation and also immunity, the longevity of the immunity, that's another variable we haven't touched yet, right?
No.
So if you get vaccinated today, you may have a scale of 1 to 10 already, right? In terms of immunity, whether it's neutralizing antibody or T cell.
Yeah.
And then, we have a study that is already accepted in Lancet Microbe. We hope that it will come out in a few
Congratulations.
weeks. Thank you. So what we have is that from the infected cohort in Singapore, at least, we have already demonstrated that their neutralizing antibody levels are not equal, which is expected, as I said, individual variation. But even if we have the same neutralizing antibody, to say on the scale of the 1 to 7, right, you are on 7, top 30%. Their immunity waning or decay, that rate is different. Okay. So at the population level, whether you're infected or vaccinated, the absolute level and also the decay, the speed of waning over months and years is going to be different. All right.
So that's what I think you've extrapolated that data, and there were people who will have longevity of maybe protection for weeks versus some decades, right? Up to 40 plus years.
Yeah. So our range is 35 days to 41 years.
35 days. Wow.
To 41 years. So that's the reality. That's real data.
And you haven't seen any correlates, any predictability, any correlates?
No, because these are the people, got infected in Singapore, and Singapore we control so well. So none of these exposed to reinfection, so we don't have reinfection in this cohort, so we cannot have correlates, right?
Yeah. Wow. Linfa, this has just been such a fascinating talk. I'll cross my fingers and pray to all the gods that maybe you'll have some more time within the next couple of weeks or month or so to do another one with me, because there's so much more that we can talk about, so many other questions that I want to ask. I think the test that you've developed is a game changer. I'll do everything I can to contribute to its accessibility here in Australia and around the world.
Thank you. Because I saw this, like when I was in Wuhan already, most people will try to, okay, we need a PCR test and we need to confirm infection, without being biased and without offending people. I say, almost anybody can develop PCR test, because once you have a genome sequence and you have a computer software, you can design it. Serology is a whole different ball game, especially
listen to you. You're like
antibody
DNA. That's so 1980s.
No. It's important, but I think different labs can do it, and so I have been focusing on serology, and so I have this concept to try to do a surrogate. Basically using biochemical process to mimic this virus host interaction, and the neutralizing antibody will come in. So we call it surrogate virus neutralization. And I was fortunate enough to, partner with GeneScript, and we get a commercial product. And these guys are very visionary. They say, oh my God, this test is going to be very important. Eventually we need an immunity passport, to get to really execute this exit strategy for COVID-19. So they came up with the name to say, we name this test, the surrogate, become a COVID pass, and the abbreviated for CPAS, basically. So I thought that's very visionary, and we definitely need, of course, the CPAS will not be the only tool, we use, but it will be a very important tool for, the society and for government to use as part of the whole kind of weaponry to eventually exit from COVID-19.
There is hope. Yes.
There's a hope. Yeah. Okay.
Wonderful. Well, thanks so much, Linfa. Really appreciate your time, and we'll speak again, hopefully sometime soon.
Thank you for having me.